All right, students, here's another radical sheet with review. This again is Algebra 1 review. I know many of you probably didn't get enough repetition of radicals in here. That's why you struggle in geometry with radicals. So we've done some in class already. Here is more, a lot more. So I'm going to make this due at the end of the week. So you don't feel rushed. So I will do a few problems from each section here. As reminders, don't forget, you're looking for perfect squares. That's the way I teach it. I go into it. So I'll write down the first up to, say, 144. Okay, and remember you start with half the number and then work your way down, unless you already know it because we've done enough repetition of it. Some helpful hints. If you don't know where to start, if half a number doesn't work out nicely for you, if I check the last two digits, if 4 goes into the last two digits, so 4 does go into 24, that means 4 will go into 124. 4 goes into 40, so it goes into that one as well. 4 goes into 120. It goes into 20, so it will go into 420. Okay, that's one shortcut to help you out. That doesn't guarantee that's going to be simplified all the way down, but that at least is one way of simplifying it down. And you might have to reduce more than that. Another one is if it ends in a multiple of 25. Obviously, 25 goes into 75, so 225 will go into 275. So that would be 25 times. Sorry, 25 goes in 100 once. 4 times. 8 for 200, and 3 more, 11. So the answer is 5 root 11. Okay. Another one with 9 is if you add up the digits and 9 goes into it, the sum of the digits, then 9 will go into it. And again, 9 is a perfect square, just like 25 was a perfect square there. Okay. So 9 goes into 9 plus 9 is 18. So 9 goes into 99 11 times, and you get 3 root 11. Okay, remember here's an example of starting with half the number. That's a perfect square. 64 times 2, so I get 8 root 2. Okay, and last trick that I've taught you is if the last two digits is 0, 0, then 100 goes into it. So I'd have 2 times the square root of 100 times the square root of 5. That gives me 500. Of course, the square root of 100 is 10 times 2 is 20 root 5. So those are the key shortcuts I've taught you so far that you can use on these. Now let's go down to this section. You could reduce each radical individually if they reduce and then multiply together. That's one method of doing it. Another method is multiply all your radical parts together, get a larger number, and then reduce it from there, simplify it from there. And of course, the major shortcut that I have shown you would be to go ahead and look for the greatest common factor. So it doesn't have to be perfect squares at all. So for example, in 34, I know a 5 goes into 10. So I'd have square root of 5 times square root of 5 times square root of 2. I broke that 10 down, square root of 10 down to square root of 5 times square root of 2. And of course, square root of 5 times square root of 5 is 5. And I'm left with a root 2 left. That's that shortcut. Just as if I didn't want to use a calculator, if I didn't know 6 times 24 is 144, I would have 4 times 6, and I break 24 down to 6 times 4. Well, of course, root 6 times root 6 is 6. Root 4 is 2, and I have a 4 there. So I get 24 times 2 is 48 for my final answer. Okay. Again, shortcuts so you don't have to use a calculator. And I will do one more. Let's say it is 45. Now let's go ahead and take 47. What's the GCF between 30 and 60? Well, it's 30. So 5 times 2 is 10 first off, and then I have 30 times 2 is 60. and I have a root 30 left over there. And we know root 30 times root 30 is 30, times 10 is 300, and I have a root 2 left. Okay, so again, I'm not having to multiply up to 1800 and reduce 1800, or I'm not breaking down the square root of 60, and the square root of 30 does not break down. And then I'd have to multiply those together and then reduce. Much simpler to do that shortcut I just taught you right there. Okay, the backside now. Simplifying division of radicals. Okay, so as you recall, and it tells you, it reminds you here, leave no square root in the denominator and simplify all the radical in numbers. Okay, so remember it's called, let's do number 5. We have a square root in the denominator. Remember, that's an irrational number. We cannot have irrational numbers in the denominator, so we multiply by 1 in the term of root 7 over root 7. That's 1. When I do that, multiply straight across, I get 2 root 7 over 7. That irrational number in the denominator of root 7 is now a rational number. It's called rationalizing the denominator. If the 2 7's reduce, I'd reduce it. It does not, so I'm done. Now, another way of reducing radicals is to go ahead and, if there's 2 radicals, one divided by the other, I can just divide. It's the same thing as 42, one big radical of 42 sevenths, which then 42 divided by 7 is 6, and that does not simplify, so I'm done right there. Okay, let's see, another one. Instead of going ahead and rationalize the denominator right away, multiply on 20 here and multiply by root 10 over root 10, I can first off simplify that because they each divide by 2, and I get root 9 over root 5. Well, then don't forget, I'm going to multiply by root 5 over root 5 now. And don't forget that root 9 is 3, so I have 3 root 5 over 5. And that does not simplify anymore. So there's my answer. Okay, now in this case on 24, since the denominator is a perfect square, I'm going to leave that alone and deal with it right away. And then I'm going to have 5 times root 12 breaks down to 2 root 3. And of course, then I have root 36 in the denominator, 6. And then that 2 will cancel 3 times right there. I get 5 root 3 over 3 is my final answer. So these are just shortcuts that I'm reminding you of. So again, since that root 36 is a perfect square, I'm not going to reduce that 1236, which is reduced down to 1/3. I'm not going to go ahead and do that. Okay, but if it's not a perfect square, then I would go ahead and reduce first. Okay, that'll save me from having to reduce later. So again, 42, that's a perfect square. 39, 25 is a perfect square. Let's see. Anything else? Okay. 29, for example. Okay, there is no 27 divided 2. That doesn't simplify, but don't forget, root 27 breaks down to 3 root 3. So that's 3 root 3 times the 3 out front gives me 9 root 3 over root 2. Now I rationalize it, root 2 over root 2, and I get 9 root 6 over 2. And that does not simplify, so I'm done. Okay, I'm just trying to find anything that don't forget the square root of 1 is 1, so it's really 1 over root 3. And then I rationalize it, root 3 over root 3, and I get root 3 over 3. Okay. All right, that should do enough examples for the 2 pages here. Okay, you really need to know your radicals. You'll use them in Algebra 2, pre-calculus, and calculus. By the time you get to pre-calculus and calculus, they expect you to be able to just pop these out quick. So that's why I'm showing you these shortcuts so that you can pop them out quick as long as you memorize them and not do it the long way each time. Okay, that'll do it.